Discipline Head of Power Business Unit, Instrumentation and Controls, Tata Consulting Engineers Limited, and she'll be presenting on industrial AI.
Thank you, Siddharth. This is Latha from Tata Consulting Engineers Limited, fondly referred to as TCE. Today my topic was an overview of TCE's journey and AI applications. As most of you are aware, TCE is a 63 plus year old organization with 15,000 plus global projects and 8,000 plus employees. It is the largest pure play design, engineering and project management consultancy. There is a global footprint with Center of Excellence for Power in Bangalore, Center of Excellence for Chemicals and Hydrocarbons in Mumbai, Mining and Metallurgy in Calcutta, and Infrastructure in Delhi. Coming to iconic projects of TC over the years, we have the biggest thermal power project in 1965, which is at Trombay. It is a 150 megawatt plant with compact layout, high steam parameters, multi-fuel firing capabilities, and the nation's first electrostatic precipitator. We are also involved in design of equitably mounted cylindrical radio telescope at Ooty, which spans 530 meters and standing 30 meters tall. It is relevant even today, contributing to India's astrophysical and heliospheric studies. And we are into infrastructure business and have designed Asia's largest water treatment plant in the year 1979. And India's first 100 megawatt thermal power project, the Trombay Unit 5, was designed by us. It featured flue gas desulfurization unit way back in the year 1984 and India's tallest chimney of 275 meters, which won applause and a lot of awards for TC. We also designed the first computer-based operator training simulator for Trombay Unit 5. And then we have India's first computer-based, we have world's largest steerable telescope, giant meter wave radio telescope, which is a giant meter radio telescope, India's longest 3.5 kilometer length sewage disposal system, and India's first 1826 MLD marine outfall, which is undersea tunnel in Mumbai, and the first 800 kV transmission line spanning 405 kilometers was designed by us. Coming to the year 2001, the first barge mounted combined cycle power plant was deployed at Tanirpalli near Mangalore. It utilized ballistic tanks for stability during flights and featured gas turbine generators with inlet air chilling to enhance efficiency. It also incorporated aircraft technology, and the plant boasted of 42% fuel efficiency in its simple cycle mode of operation, making it most compact and efficient. And then we designed India's first 800 megawatt thermal power plant at Mundra. It has 5 units totaling to 4,000 megawatts. The first centralized control room for a power plant incorporating all the 5 units was designed by us, and we were the chief architects of this plant. And then coming to the mining and metallurgy industry, we have this 3 MTPA expansion Tata Steel Coke project. The salient feature of this project is the the environmental initiative which we took by reducing the cyanide by limiting the cyanide to 0.2 mg per liter, which was way beyond the regulatory requirements. Then we are partners with the International Thermonuclear Experimental Reactor of France, wherein 7 countries are involved, including India. This ITER nuclear fusion project is a revolutionary venture and epitomizes a significant stride towards harnessing nuclear fusion to meet global energy demands. We also have partnered with ISRO for the GSLV launch and introduced innovative engineering automation for handling explosives in addition to design of solid propellant rocket protection. TC further innovated a fail-proof mechanism for the quick retraction of the umbilicals on the satellite launch vehicles, which is a crucial aspect. And then we are working on 14 smart cities and 50 Amrit cities. And most of you are aware of India's unique project with 1,000 years life, wherein we have used the traditional material like sandstone and reduced the usage of concrete by applying tongue and groove joints for the structural stability. Here, though it is a revamp of the existing structure, we have used 3D structural analysis and 4D modeling, which dramatically improve the project management process, allowing for real-time visibility and proactive issue resolution. And then India's largest Pradhan Mantri Awas Yojana project in a single city, Navi Mumbai, is supervised by us. And then we do have PMC partnership. We are the major contributor for PMC partnership for India's first high-speed rail project from Mumbai to Ahmedabad. And here we are partnered with Japanese firm in addition to two Indian partners. We are mission partners for Chandrayaan 3, the world's largest green ammonia project in Oman, was designed and detail engineered by us in 2022, and India's first hydrogen fueling station in Ladakh, wherein the altitude was a critical issue for design application, was engineered by us. We are also currently engineering India's first semiconductor plant and solar PV glass plant. And the recent achievement is the acquisition of CDA Engineering Solutions LLC based in USA, which works on chemical and energy industry in addition to um, battery storage, low carbon capture, etc. Now coming to the today's topic of industrial AI. Industrial engineering plays a very vital role in improving industrial process and increasing efficiency and productivity. With advancing technology, AI is increasingly becoming a transformative force in industrial engineering. I've listed on a very few industrial AI applications. One is smart manufacturing, where the use of machine learning and other AI technologies, we can optimize and automate process within the manufacturing facilities, which is already spoken about by many of the speakers before. Coming to digital twins, these are virtual replicas of physical industrial assets or systems of processes, which leverage on artificial intelligence to optimize the performance, predict outcomes, and enhance decision making. They also integrate real-time data with simulations and AI algorithms to provide insights, improve efficiency, and enable predictive maintenance. And Singapore is recognized for creating its first digital twin of an entire nation. We have digital twin technology across multiple sectors, ranging from healthcare to solar PV maintenance. Next is the data analysis and predictive maintenance, which we are trying to implement in most of the industrial applications. Here, the intelligent systems use machine learning techniques to analyze the vast amount of historical data, extract the patterns, identify significant trends, and provide recommendations for maintenance before the failures occur. This information is further utilized to optimize resource planning, predict failures, and improve production schedules, resulting in increased efficiency and cost reduction. Supply chain optimization is yet another industrial AI application which is very crucial. By leveraging machine learning and optimization algorithms, companies can analyze historical data, demand patterns, and market trends to make accurate forecasts, streamline inventory management, and enhance logistic operations, which results in reduced delivery times, reduction in cost, and better customer satisfaction. Then we have quality control and defect detection. AI technologies, including computer vision and pattern recognition, are employed in quality control and defect detection process. These AI systems can analyze visual data and identify defects or anomalies in products, ensuring high quality standards are met. Now, we'll continue with a few applications developed by TCE. The first one is artificial intelligence in defect detection. See, currently quality is of utmost importance, whether it comes to manufacturing industry, construction industry, or the health industry, right? So here, earlier we used to have manual inspection methods, which are often time consuming, subjective, and prone to human errors. However, recent advancements in computer vision, particularly with deep learning models like CNN, the convolutional neural networks, and object detection frameworks such as YOLO V8 have revolutionized the automated detection of defects in various materials and medical images. This is the homepage of our defect detection tool application. This is a combination of X-ray computed tomography for structural analysis using computer vision software. Uh, Basically, when an input file, which is generally in the form of a PNG or a JPG, is uploaded, we can see the output files, which gives a clear view of the defects like pores, the exact location around the x and y axis, and the affected area. In addition, we also have a heat map of the affected area. This is as far as concrete structures are concerned. We also have the same application which could be used for steel defect detection. Here you can see frays and holes and cracks also, which are displayed in the output image along with the heat map of the affected areas in addition to the exact location and area. The same tool can also be applied for making a report of medical x-rays through computer vision. This is the input image. You can see the output image, which shows a clear indication of the fracture and the affected heat map or the heat sensitive area. The various steps involved in development of this software include data collection, image annotation, image enhancement and augmentation, model training, model testing and deployment. We have yet another application which is a PDF to P&ID conversion. The PDF to P&ID conversion tool is a very innovative solution designed to automate the conversion of scanned or digital PDF based P&IDs into editable CAD formats. This tool leverages some advanced image processing techniques and machine learning models to accurately detect, recognize, and place critical elements such as pipelines, line tags, arrows, and symbols in correct locations, scales, and orientations. By automating this process, the tool effectively reduces the time and effort of the manual drafting and ensures accuracy in engineering documentation. Because of the reduction in manpower, we also have cost saving, resource optimization, time saving, quality improvement, and productivity gains. We are further working on this model. This is the home page of the tool. This is where we load in the data. Once we load the P&ID images for processing, we get the output. This is the input PDF or scanned file, and this is a developed AutoCAD file. We are still further trying to optimize this tool, like we are trying to improve the symbol database and provide real-time editing capabilities and cloud-based processing for this tool. Then we have generative AI, which is developed in our own organization and is deployed within the organization. Basically, TC is a knowledge based organization. So we have large volumes of data in our organization. So what we are trying to do here is where anywhere in the world people should be able to access the specific required data. So we have developed this tool, and for example, if someone wants details about the AI tools in our organization, they can just key in the requirement in this web page, and they get the details, whether they're at site or in working in a remote location. Predictive maintenance for rotary equipment using AI techniques. This, most of you are aware, it is applicable for pumps and motors and is available by many manufacturers. We also have energy optimization in industrial furnaces by leveraging AI. This model is a predictive model to forecast gas consumption based on temperature data across different heat zones, optimizing energy use in furnaces. This is yet another development, which is the intelligent single line diagram generation. In this case, we have to enter only the voltage, frequency, the power rating, and the number of feeders and the feeder ratings, and select the configuration like a single bus, dual bus, or a triple bus configuration. The output will be a AutoCAD generated single line diagram with all the feeders, feeder ratings, and metering and production. These are a few digital point solutions for power plant engineering which we have developed. The coal inventory management and optimization, boiler modeling and performance optimization, pump performance monitoring and diagnostics, transformer performance monitoring, switchgear health monitoring, remote energy analytics, condenser performance, cooling tower, and monitoring and solar power forecasting and diagnostics. Thanks for your time, ladies and gentlemen.
Thank you, Ms. Latha, for your take on industry.